Hello, hope you had a great day. We are still talking about some special functions. Tonight we're going to talk about a piecewise function. And actually, in its purest form, the absolute value function that we talked about last night and we worked problems with today in class is actually a form of a piecewise function. So we're first going to ponder, I wonder, what is a piecewise function? How do I graph a piecewise function? I did absolute value before because it's easier to not think about it as a piecewise function and graph it than it is to think about it as piecewise. But it is. So here we go. A piecewise function is a function that follows a different path. It follows a different path depending on the x values that you're plugging in. So let's first look at two separate functions completely separate. This function says that it follows the rule x minus 2, so y equals x minus 2, whenever you plug in a value of x that's less than 1. So can I plug in 0 for this function? No. Can I plug in 10 for this function? No. I have to pick values that are less than 1. The thing that you want to understand is that because we can get so very, very close to -1, we actually plot that as our first point. This is what I call a critical value. You'll hear me refer to it a lot. Critical value. Write that down. Sorry, that's like really crumbly. Oh, goodness. Goodness, goodness, goodness. The neater I try and get, the worse it looks. Critical value. Okay? So we're going to just make a table of values for this. Very simple, okay? We can only pick values that are less than -1. So we're always going to plug in our critical value, and then we're going to go less than that. So like -2 and -3 and -4, okay? If I plug in a -1, -1 minus 2 is -3, -2 minus 2 is -4, -3 minus 2 is -5, -4 minus 4 is -6. So you see what's happening here? We have I have an open circle there because it's less than exclusive, all right? Then I have -2, -4, and I have a dot there. I'm going to make an X. And then I have -3, Oops, I think I put that in the wrong spot. I started in the wrong spot there. Let me erase here. Go back to my pen. So I have -1, -3. And I have an open dot there. Then I have -2, -4. And then I have -3, -5. If I had room for -4, -6, I would go ahead and put that on. And then I'm going to connect it. Notice that I don't go to the right at all, okay? Now, what happens if my other function is f of x is equal to x plus 3? But that's only for values of x that are greater than or equal to 1. So this tells you what x's I can plug in. This tells you how it's going to behave. So I'm going to make another little graph. And I'm going to plug in -1, and then I'm going to go to the right. I'm going to go to the right. So I have -1, 0, 1, 2. If I plug in a -1, then I have -1 plus 3, that's 2. If I plug in a 0, I get 3. If I plug in a 1, I get 4. Oops, there's Eli. And if I plug in a 2, I get 5. All right? So let's graph this. I have -1, +2, and that's a closed dot. So I'm going to make an open dot, and then I'm going to try and color it in, okay? That's closed. Then 0, 3, and 1, 4, and 2, 5. And you see what I've done here? I have this part of the line because it's only good for numbers that are greater than or equal to -1. Notice in both cases I used my critical value as my starting point. That's important. Critical value always is your starting point for whichever table of values you're constructing. Okay? All right, now what a piecewise function does is that it puts both of these equations together. It puts both of these equations together to make a single function. So the way we interpret this is that my function, f of x, follows the path x minus 2, or follows this rule whenever I plug in values that are less than my critical number. I always include my critical number. This is my critical number, or critical value. And then the function, I'm going to pick a different color. Then the function follows x plus 3 when we have x values that we're plugging in that are bigger than or equal to -1. Again, look at my critical value. It's the same point, critical value. So whenever we go to graph a piecewise function, our strategy pretty much stays the same. You're going to graph them separately, individually, but on the same coordinate plane, and you're going to always plug in the critical value as a point on the graph in whichever piece it occurs. Then you're going to pay attention to the inequality signs, and you're going to use that rule inclusive. You're going to use a closed dot for greater than, equal to, less than, equal to, and then you're going to use an open dot whenever you have just the exclusive, just greater than or less than. Okay? So we're still working with the same problem. We've already graphed it separately. We've learned what it means to put it together in a piecewise function, and now we're going to graph it on the same coordinate plane. So I'm going to, this is my rule, and these are the points that I'm allowed to plug in. Okay? This is the rule. And these are the allowed points, allowed x's. Okay, so I got to plug in. I've always got to use my critical value. My critical value, that's this. So I got to start there. It's going to be an exclusive, so I have to remind myself to leave an open dot. And then I'm going to plug in values to the left, -2, -3, and here's my y value. So -1 plus 2, that's 1. Oh, that should be -2. No wonder I was thinking this looks different. Okay, I need to change this to... bummer. This needs to be -2 to go with this. So I plug in -1 minus 2 and I get -3. -2 minus 2 is -4. -3 minus 2 is -5. And I'm going to graph it again. So I'm going to go -1, -3. And I'm going to use an open circle. -2, -4. And -3, -5. And there's that part of my graph. Okay? Now I'm going to graph f of x, the part that says f of x is equal to x plus 3. And then I get to plug in values that are bigger than -1. So again, I'm going to start with my critical value. Always start with my critical value, whether it's inclusive or exclusive. So I'm going to plug in a -1, but now I'm going to pick values that are bigger than -1. Like 0, 1, and 2. and I'm going to plug those in. So if I plug in a -1, I'm going to get +2. If I plug in a 0, I get 3. And if I plug in a 1, I get a 4. And if I plug in a 2, I get 5. And I'm going to plot those points. So at -1, I'm at +2. And I'm going to close that circle in. Okay, closed circle. And then I'm at 0, 3, 1, 4, 2, 5. And then that's the line. And you just graphed a piecewise function. Now let's look at the domain. Remember, our domain is our left and right values. So turn your pencil vertical and ask yourself, what's the smallest x value that I'm going to have? Well, this one keeps going down to +infinity. I'm sorry, down to -infinity. Left to -infinity. So that's -infinity. Now you have to be careful that you don't miss any numbers. So put your pencil vertical and just trace it. And notice that here at -1, at first I have, as this lower one, I have an open dot, which would mean I'd have to exclude it, but at the same time it's closed up here, so it is included, and I keep going. And I get -infinity to +infinity. This one will not always be -infinity to +infinity. There could be x values that are excluded. Our range, all right, this one keeps going straight down, and this one keeps going straight up, but look at what's happening in here. Look at what's happening in here. All these y values are missing. So I say this. It's going from -infinity to -1, not including it. Then it jumps, so I get a union. And then it picks up again at -1. And then it goes to, I'm sorry, these are y values. Oh, I'm butchering this. This y value is -3. And then it picks up again at the y value of 2 and goes on to +infinity. Okay? Let's try another one. We're just going to, this is 3 pieces, so we're going to just do exactly the same thing with 3 pieces. All right, so I'm graphing this part that's f of x is equal to x minus 3. What values do I get to plug in? Well, I'm going to start with my critical value, -1, and I got to go to the left. So -2, -3, and I'm going to plug that in and calculate my y's. So I'm going to get -4, -5, -6. So I'm at -1, -4, open, -2, -5, -3, -6, and that's off my graph, so I'm going to stop. Okay. And then I'm going to pick up my middle section. My middle section behaves like this rule right here. But for this, I can only plug in, I notice that I have 2 critical values. This is a critical value, and this is a critical value, both -1 and 1. So that's where my table is going to go from. All right, it's going to go from -1 to 1, and you get to pick some points in between. So just pick 1, just pick 0. And then here's my y values. If I plug in a -1, I get -1. If I plug in 0, I get 0. And if I plug in 1, I get 1. Now I'm going to graph that. Actually, I should have put that in a different color. I'm going to change that to red. So I get -1, -1. This is a closed dot. And so is this one, because they're, oh, nope, that one's open, open. So I'm going to go -1, -1, closed. And then 0, 0. And then 1, 1, open. And that's where that segment ends. Boom, just like that. Nothing more, nothing less. Now for the third segment, it's following this rule. All right, what values of x do I get to plug in? Well, I get to plug in ones that are greater than 1, and I always have to start with my critical value. So I'm going to start with 1, and then I'm going to do 2 and 3 and see what I get. So if I plug in a 1, that's 3. If I plug in a 2, that's 4. If I plug in a 3, that's 7. Okay? So 1, 3, and it's closed. And then 2, 4, and then 3, 7 is off the, oops, this should be 2, 5. You're probably wondering what Mrs. Westrich is doing. 2, 5. And then 3, 7 is further up, and so it's going to go like this. All right. All right, so we graphed it, and now our domain. We don't have any gaps, so it's going to be negative infinity to positive infinity. But we do have some gaps on the y's. All right, so my range is going to go from negative infinity to negative 4 union. Then it's going to go from negative 1 inclusive to 1 exclusive, and then union, and then it's going to go from 3 inclusive to positive infinity. And I can go back over that domain in class tomorrow. Okay. Now we're going to work backwards. So what you have to do is you have to kind of figure out the slope of each line segment and then write an equation for that line. All right. So let's start with this left-hand segment right here. This is segment 1. Okay. My slope is down 2 over 1, down 2 over 1. So my slope is positive 2 because that's going uphill. And then I have this point negative 2, 0, negative 2, 0. Okay? So I'm going to plug that point in. So I have y minus 0 is equal to 2 times x minus a negative 2, or plus 2. Sorry, my pen is messing up. Must be getting tired. So y is equal to 2x plus 4. That's one part of our piecewise function. Now for the second segment, this is segment 2. Sorry, that should be over. Segment 2. I'm going to go up 1 over 2. So my rise over run is a half. So this is 1/2. Okay. And then I'm going to write an equation. So I'm going to pull this point right here, which is negative 2, positive 1. So I'm going to go y minus 1 is equal to 1/2 times x plus 2. So y minus 1 is equal to 1/2 x plus 1. So we get y is equal to 1/2 x plus 2. So here is our function f of x equals 2x plus 4 if x is less than negative 2. I'm not going to worry about the domain and the range. We'll talk about that tomorrow. And then it follows 1/2 x plus 2 if x is greater than or equal to -2. Okay? All right, so here's 3 pieces. Why don't you go ahead and try this and then hit pause and then come back and I will do it with you. All right, here we go. So this left segment, this is segment 1, segment 2, segment 3. This slope is 0. And this is the line y equals -1, -2, -3. Y equals -3. Segment 2, my slope is down 1 over 2. So this is m is equal to -1/2. It's going downhill, so I know it's negative. And then it's down 1 over 2. And so I have y. I'm going to use this 0, 0 point and go y is equal to -1/2 x, because if I plug in 0, 0 for y, the x1, y1 just goes away. All right, and then segment 3, again, I have negative slope. It's down 3 over 1, so my slope is equal to -3. And then I'm going to use the point, well, let's use this one. You know what? I can use 2, 0. Okay? And so I get y minus 0, so that's just y is equal to -3 times x minus 2. So I get y is equal to -3x plus 6. So my function, my f of x, I'm going to kind of just put it down here, is equal to -3 if x is less than 1, 2, 3, -3. It's going to equal -1/2 x if x is between -2 and 0. So we go -2 less than or equal to x less than or equal to 0. And then it's going to go -3x plus 6 if x is greater than 1. So notice we kind of have a gap between 0, x is 0, and x is 1. So we would have to exclude that from the domain. And I'll go through the domain with you guys tomorrow in class, okay? All right, these are the problems that we're going to do in class. There's not too many of them. Some of them require a little bit of work. So I'll talk to you tomorrow. Thanks for listening.